you lose sleep at night, and our speaker is Nathan Van Gheem from the Wildcard Corp. I just wanted to do a couple quick kind of housekeeping announcements. First of all, please silence your phones as per usual. There is a evaluation form to fill out on the website. Please do that. That's very important. And since this is a streaming session, we have to use this throwable microphone. So if you have a question towards the end and there's going to be time for questions, please just, I guess, catch my attention or catch the speaker's attention, and I will actually physically throw the microphone at you. Please catch it. Don't let it hit you. So without any further ado, here's Nathan.
Hi, can you guys hear me?
Yes.
Okay. Thank you for having me. Thank you for coming to this talk. I hope the provocative title wasn't, we did it on purpose. Like, we want you guys to, the purpose of this talk is going to be getting people to care about security more and learning a little bit of how to care about it more. So hopefully, if you don't lose sleep at night, maybe you will lose a little bit of sleep at night. And think about this more. A little bit about me. I'm the security team lead for Plone. Plone is an open source content management system written in Python. It is used by some 3-letter agencies in the government. I have been doing high security deployments, CMS deployments using Plone and other Python web technologies for like 6 years now. I have a lot of open source development experience. I've helped mitigate, countless attacks with the 3-letter agencies that Wildcard Corp provides solutions for. A little bit about Wildcard Corp. We specialize in secure web solutions, of course. We do a lot of open source stuff. We care about open source technology. We care about open source being secure. We care about Plone. We do Pyramid, Django, and other web technologies as well. But we do a lot beyond just the CMS. We provide a lot more infrastructure to even provide additional security. A little bit more about me, just so you can know where I'm coming from. I don't have a lot of PHP experience, for instance. I do a lot of programming. I'm a programmer by trade, engineer. But I do some sysadmin work. I do some DevOps work. So I have a wide breadth to be able to understand how to provide all this security for web applications. But I know there's a lot of PHP on campus, so I'm going to talk a little bit about PHP at one point, but keep in mind that's not my expertise. So because in our as a company, for us, we mostly just recommend not to use PHP. So just keep that in mind. I'll try to be as agnostic as possible, but these are the technologies and these are the viewpoints I'm coming from in a lot of the things I do. And again, the purpose here, let's get you serious about web application security, serious about threats that you might have with your deployments. Make sure that you can change the culture and attitude in your organization to make the right choices in choosing solutions and what you develop and how you integrate solutions together. So you can sleep at night, and that if you're an engineer or developer, that they can sleep at night. That you're confident in what you've provided as solutions for people. And why should you care? Because maybe it's moral. Maybe you're housing people's personal information. Maybe it's the moral thing to do. Maybe your reputation matters. If you guys get hacked, in whatever way it is, does it hurt your brand? Does it hurt your bottom line? Is it important to your product? Is it important to your company, the university? These are things you have to think about, because you might not think it's ever going to happen. You may do things that aren't, good security practices here or there, thinking it doesn't really matter. But one screw up can lead to a massive problem, because just one thing can let somebody in and ruin everything. Everybody's data's gone. And it might cost you money too. Anybody remember the celebrity Apple breaches? I mean, wasn't even necessarily a security flaw. It was just the celebrities not taking care of their data properly. Apple responded. It still was a branding problem for Apple. Like, it affected them. You don't want your users getting their data stolen, however it might be. Even Mark Zuckerberg, he got all of his accounts hacked. Like, someone like him doesn't even have different passwords on each account. Like, this isn't even like, these are examples maybe not even of like security flaws, but these things matter, You got to think about what's going to happen with your data in your application. This one affected me. A lot of government employee data was stolen. 22 million people's data was stolen. I get free identity theft protection from the government now because of this thing. So it costs them money. And it looks really bad, obviously. It's a bit embarrassing. Costs money to your brand. Health data is very important, for instance. You don't want to lose your private data of your customers. Why should you care? These are the things you think about. And maybe your application doesn't necessarily provide private data, but people are sharing passwords between systems. Maybe you can get enough information from one system to get into the next system. And maybe that web application you haven't thought about for a couple years hasn't been looked at. What are you doing with it? Are you still keeping it up to date? Or is it now a zombie site that has a bunch of ransomware, adware, part of a botnet or something? You don't know if you're not taking care of it. And then there's even 0 days. This has happened a lot with Drupal and WordPress lately, it seems. These are vulnerabilities that people don't even know are happening. They're finally known when the 0 days release, but there's no known fix for it at that time. They've been exploited in the wild. Like, how frightening would that be? There's some add-on that you have installed, has a 0 day. Like, what do you do? So in this talk, I'm going to focus on CMS a little bit. I mean, CMS seems to be the most frequently exploited, and part of that, the reason for that is it's a lot of exposure. It tries to provide a lot of features. You're providing often many users the ability to create many different elements on your site. So it's harder to secure. It's a lot more surface area. Before I get into the details about what I'm going to cover, I just want to cover some basics, because these are things I'm not going to cover in detail, but I don't want to lose my street cred because I didn't mention some basic things that you should be doing. I can't cover everything, so I want to say you should have firewall rules that you can't access anything. All your ports are locked down. Shouldn't have SSH open to the world. You should require VPN access to get anything to your servers. You should have password policies. Should be on the mailing lists of all of your of the security mailing lists and all of the applications or software that you use to make sure you get all the up-to-date security information that's going on. You should not be running any of your web applications with privileged users. All these things, these are things you should know. Look them up, Google them. These are basic security precautions that you should already be doing, but like this, it'd be a boring talk if it's the stuff I would talk about, because everyone talks about that stuff. I mean, you get that information everywhere. Some things I won't cover in detail here are DNS security, physical security, social engineering. I mean, I'll reference them, but these are not like, I'm not going to talk about how you prevent social engineering, physical security, and I'm not going to go in depth into OS security. I'm focusing primarily on web application security, understanding web application risks, understanding common web application exploits. And in doing this, I'm going to go through like the top 5 risks as I perceive them. They're not in necessarily any particular order. They're what I've seen over the years. They're what I've seen has been tried over the years many times. Yeah, they're all of them. I'm getting some of all of the definitions and some of the data from OWASP. It's a security project for helping to provide good security practices for open source or for just any project. Good security guidelines to go through, lots of good information on OWASP website that you can read through. And they have a top 10 that some of these are pulled from. So first one, I'll talk about a SQL injection. A SQL injection attack consists of insertion or injection of a SQL query via the input data from the client to the application. So what that means is you have someone input into a form or input a URL, and the data is not filtered correctly and allows users or a malicious user to gain more access to data or do specific actions that they shouldn't do. And the risk of this, if there is a vulnerability, they potentially have full access over your whole server, over your whole web application. Not necessarily, not your server in a sense, but the web application, because they can completely drop your tables maybe, or they can select data from the database that they shouldn't be selecting. They can probably, bypass some sort of authentication then as well and get user data. And some SQL databases allow you to do system commands from SQL statements. At least some of them allow you to shut down the SQL server from it. Kind of how it works is you get input that has escaped statements in it, so it's like rewriting the SQL statement as you did not intend. And so it ends up, this one where you think you're just going to insert some value into the database ends up dropping the database instead. And it can be, like I said, URLs, form data. Here's an example of someone trying to use the attack to do something clever, for scanners reading license plate data, try to get them to do a SQL injection. This has been a popular XKCD strip. Sorry, I went down too fast. So what do you do about this? Well, if you can, don't write any SQL yourself. Use object relational mapping for all your stuff. Make sure any add-ons you use are doing object relational mapping as well, that they're not writing any raw SQL. If you do write SQL, you have to parameterize your inputs. So like, don't just do string concatenation. If you have ever written a SQL statement, you should know what I'm talking about. You can use stored procedures, so you're not even writing any SQL. And you can always make sure all your input is escaped, of course. Some web application firewalls will detect these attacks and just block them. So consider Web Application Firewall for helping mitigate ones that you're not aware of. Or if you can, don't use SQL. Maybe a NoSQL database would be a good idea. Number 2 is denial of service. Denial of service attack is focused on making a resource, site, or application server unavailable for the purpose that it was designed for. The risk level here is medium. Your site can be completely down when this attack is executed, but no data is compromised. It's the easiest attack to perform. Anybody can perform a denial of service attack. So you're more prone to get attacked by this maybe than anything else, but at least you don't get any sensitive data compromised. How it works, attackers will target known slow pages on your site. They'll try to bypass your caching. If you have a large site, say you have 150,000 pages on your site and you don't have a warm cache, they'll try to crawl your site really fast, and then all of a sudden your backends get overloaded because maybe your backends don't have the capacity to handle that many simultaneous requests at one time. An example of this is someone might write a script to run and make many requests against a web server. A DDoS is a distributed denial service. This is the same thing as a denial service, but it's distributed against many servers in various parts of the world. And so you can get more throughput, more network traffic, more simultaneous requests. A lot of these executed attacks will be using botnets, zombie computers. These are compromised CMSs maybe, compromised machines, personal machines at home that have software ready to be activated when someone decides to buy a botnet and run an attack against the particular server. Another type of DDoS is called a low orbit ion cannon. I don't really know the history of the name, but that's why it was given. It's actually written in JavaScript, so it's like a hosted DDoS service. So anybody can put this up, and it's just JavaScript that runs in the browser. You just say hey, go to this site and start attacking, go to this URL and it'll start attacking the site for you. And it'll just use JavaScript to make tons of requests in the browser. So as long as that user has that browser open, he's helping attack this site. So it's usually powered by social media, and it just generates random URLs trying to bypass cache. So some solutions for this, again, Web Application Firewall. They're good. They can block attackers. CDN and caching, load balancing gives you more power. So you're not actually hitting your backend as much. Keep your cache warm. So maybe have things that will crawl your site for you, just so you know even the depths of your site that aren't that popular, if you have a really large site, are getting put into cache. Consider serving stale content if your application servers go down. Maybe you have a backup that's just a stale copy of your site. You can have your proxies configured to fail over to it. And some more, make sure you profile your code too. Know where the slow parts of your application are. Maybe you can optimize them, maybe you can fix them. Most programming languages, CMSs have add-ons to measure the page rendering speed. You can do, I'm not going to provide specifics because I know what I would use in Plone, but there's a couple of different ones for profiling in Plone. And you don't even need to use the CMS or application-specific one. You can use your Nginx or Apache server to actually measure the page rendering speed for every request, and then you can run reports in the logs to see which ones were slow. You can do, using grep and everything, is just pull in, hey, what are the slowest pages? Monitor your traffic, so know what's regular. If you can have any alerts set up to monitor when there's irregularities. You can do rate limiting, perhaps. For the low orbit ion cannon, you can block by refer. If you know that a particular site is hosting an attack against you, you can just block that site because the refer will be attached to every request when a user goes to be a part of the attack. Cross-site scripting. Cross-site scripting attacks are a type of injection in which malicious scripts are injected into otherwise benign and trusted websites. Cross-site scripting attacks occur when an attacker uses a web application to send malicious code, generally in the form of a browser-side script, to a different end user. This is usually, so what this means is usually someone figures out how to get JavaScript executed on the client that should not be executed. JavaScript by the user viewing the page executed when it shouldn't be. This is a really bad attack. I mean, they basically can do whatever they want if they know about your web application, because they can make requests on behalf of you using JavaScript. They can do whatever they want with JavaScript if they're able to inject it, if they're able to compromise it. So how you fix it? Always validate input and output. You can validate your input going in, making sure that people aren't inputting script tags or whatever into untrusted sources. And on the way out, you can escape the markup to make sure that those don't even do anything, even if they did input. And it targets already logged in users to cause malicious actions, right? So there's two types. There's a persistent type. If they're able to have something stored in the actual database that renders every single time the page is loaded. And then there's the reflexive type where there's it's like embedded in a URL maybe. And in the reflexive type, they have to get, the attacker has to get a user to click on a bad link in order for it to execute on their site. So this is kind of what it might look like. You can see in the URL has a script tag, and it just shows an alert box in this case. But you could just run whatever you wanted on that page. Yeah. So how it's exploited is a malicious user has an ability to add this somehow to your site, and then JavaScript runs and renders it. So, and this is just an example of, if you're familiar with JavaScript and jQuery, if you're taking input from a variable and just plainly appending it to HTML or whatever, it'll render it, and it'll execute it. Solutions for this are, again, Application Firewalls help. Validated user input, escaped user output, and using JavaScript libraries that are safe by default helps as well. Like React doesn't let you render raw HTML anywhere. It escapes everything. You have to specifically go through hoops to render unsafe HTML. Next one is CSRF, cross-site request forgery. Cross-site request forgery is an attack that forces an end user to execute unwanted actions on a web application in which they're currently authenticated. It's kind of similar to cross-site scripting, but it's not getting code to be executed on that browser, on that user's computer. It's just causing a URL to be requested that does a particular action, does a state change, maybe unpublishes a page or changes the content of a page. So you can maybe deface a site or bring unpublish the front page of the site or something like that. So the target user, like if whoever's being targeted here needs to be authenticated on the site while they're executing it. The attacker needs to draw the user to the site that's already authenticated, or click on a URL that is an exploit. So an example of this would be, someone makes a comment on a blog post or something. And they say, hey, great post, but they got an image tag that is actually an exploited URL. It's not actually an image. And then they also have a link that is an exploited URL. Well, when a logged in user goes and looks at the comments of the page, that image tag is just executed because the browser is going to try to get that image, and that's what's specified in the image tag. So if you allow your users to just input images like that, and you have a CSRF vulnerability, this is what could happen. So how do you fix it? Well, you hope that your frameworks that you're using, your CMS, or whatever it might be, has built-in protection against this. That whenever you're doing a state change, it requires what's called an authenticator token, and these authenticator tokens are unique to each user. Most frameworks provide mechanisms to do this, provide the token on particular requests that are needed, and to verify those tokens. If some Plone, for instance, integrates the CSRF protection at the database layer. So if an authenticator isn't provided and you're about to commit to the database, it says, hey, wait a second, you're not allowed to do this because you haven't verified you are who you say you are that's making this request. You're still logged in, but you don't know that that user actually initiated that action because that authenticator token wasn't provided with the request that changes state on the application. The last one I want to talk about is kind of like a catch-all. It combines a few of the different ones on the top 10, OWASP top 10, and I just wanted to do it this way so I could fit 5 in here. It's just access control. Thinking about making sure users make the right choices and that they're not abusing things. Misconfigured workflows, things that are public by default. So a page, if you have a page that's public by default, well, maybe the user doesn't always want to have a page public by default. Users can upload file attachments that provide potential private data associated with them, maybe workstation numbers, user IDs, things that can be used against them, things that can be used in phishing emails. So a lot of the new CMSs provide REST APIs, but make sure you know what data they're actually providing. Maybe they're providing user data, a little bit more metadata than what you want your potential attackers to know about your site. And some solutions here. So assume your users are going to be lazy. So try to provide sane workflows for them, so they're not just by default publishing everything that they add to a particular site. Especially if they have like a members area. Like we had a site where we had a members area, and users didn't realize that other people could see their stuff in their members area, like their personal folder on their site, if they had it published. They thought it was just because they had their own area that it was private. So in that, in know your application, maybe you can even block stuff that could be potential problem areas at the proxy server, just with regular expressions. Block things that could be potential problems. You can scrub files with XFtool and Linux, so you can provide like wrapper tools that will scrub the metadata from files when they're uploaded. So those are my top 5, and now I kind of want to go deeper. So that gives you an understanding, hopefully, of what some of the different risks and exploits that are performed against you might be. And I want to kind of talk about what can you do to go deeper to actually provide more security, maybe prevent some, even if there is an exploit, maybe they'll catch it even if there's a 0 day. Maybe you'll catch it and you won't be exposed because you provided these additional mechanisms that helped you. And some of these, I also want to say that some of these are much more involved, can be complicated depending on the deployment. These are suggestions, ideas. Take what you need, know your application, know what you need to do for your application to be able to sleep at night, for instance, right? Caching. Always provide some caching. DDoS protection helps your performance of your site. Varnish is a great caching proxy. It's been around for a long time. If you don't want to configure another caching proxy, Nginx, Apache can do okay. Apache Traffic Server is another one. It's a caching proxy and decent general purpose proxy in one. Know your content, know how to tune it, know how to provide better performance. Just give you an idea what it looks like in server diagram kind of is you have all your users hitting the caching proxy, which then sends the traffic back to the web application if it's not in cache. So you're providing a little layer of protection there. CDN, Content Delivery Network. If you're not familiar with this, it's a good time to. Often they provide web application firewalls in addition to just caching. You can often configure them to serve stale content if your backends are down. So even though your backend might be down, no one will know because it's serving out previously cached content. Always keep your cache warm so it's performing well. Cloudflare. If you don't know about Cloudflare and you want a simple CDN, you can get free CDN with Cloudflare. Like it's like, you know, it's not great for the free level. You can pay more if you want some more robust features and everything, but give it a try. Be prepared for the stampede. You know, sometimes you'll just denial of service yourself if you have a ton of, if you're trending on social media, you're not ready for it, your servers can't handle it, you don't have any caching, or you're not caching that particular page right. So CDN is, you know, distributed across the world, so you get lower latency, better performance, and your CDN would then connect to your caching server in an application, or maybe you don't have a caching server if you have a properly configured CDN, so it just go directly to your application, just kind of showing you how the flow of traffic goes there. And Web Application Firewall. Again, I kind of talked about this before. Usually CDNs will provide one, or that's a good place to implement the WAF. Cloudflare is an option. They have a good WAF. Very cool interface for seeing all your blocked requests. They'll give you graphs and information to see like what happened and everything like that. Mod security is one that's been around for Apache for a while. And then there's an Nginx one that translates mod security rules to Nginx. And this is kind of a, so you can have, you know, your application firewall, different layers. Kind of looks the same. You're just adding another layer of protection. So again, just so you know, like web application firewall, that can protect against cross-site scripting maybe. It can protect against denial of service. So might be able to catch some things for you. It can protect against SQL injection. Load balancing. To provide even better performance, protect potentially against denial of service, you can provide multiple application servers that are load balanced between them to kind of like increase your performance and throughput. HA proxy is a great one. But Nginx, Apache, Varnish, some CDNs will even do it. These are ones that can do it as well. And HA proxy is kind of the best one. You get better like health checks for your backend, health checks and stuff like that. And then you're in this case, the diagram showing your caching server going to multiple application servers that are configured. And that would do like round robin or random distribution to those application servers. So when a request comes in and say, hey, it'll just decide which one to go to, and hopefully it's random enough that they all get equal load. And then consider your database selection. Can you use NoSQL? Does your database support replication in a sane way? Is it a usable way of replication? Replication's important again, because you can provide now multiple database servers so you can get better database performance for your applications. These can be on different networks even, so you got robust failover. Say you have one server cluster on AWS and another on another cloud provider or your own internal servers. Maybe you got a backup in case your AWS goes down, and you have another place where your data might be safe, geographically dispersed. And this is adding more to this diagram. Now you have database servers that your application servers are connecting to. So once you have replication, now you could even perhaps do read-only sites, because you could have a read-only replicated database so your public only ever sees a read-only site. So then even if there is an attack executed, well, that site is read-only, so what can they do? Most like PostgreSQL and ZODB and other database systems allow you to do read-only mode. Consider like what parts of your site actually require writing to the database. Maybe you just want commenting. Well, if you want commenting, well then you can't do a read-only database maybe, right? But what if you move to Discuss, that cloud-based commenting system? Well, now you can maybe do read-only mode because your comments are stored somewhere else. They're not stored on your application. Are there tools on your platform that you can do more advanced read-only setups? Wildcard developed a few to help people for Plone. One is Wildcard read-only, which allows you to do read-only mode on a database that is read-write. So your application server thinks it's read-only, and it will error if it tries to write to the database. So then you don't have to do the replication. It's easier for people to do simple, more safe application servers. And then we also wrote a product called Wildcard.Lockdown, where you're only allowed to write to the database if certain criteria match in your application. Otherwise, they'll just error out. So in doing these CDN, caching, load balancing, replication, you get a lot better performance too. You get better user experience. People will see your page rendering times increased, see your responsiveness increase. If you do warm caches, your site will render faster because they're not going to the back end every single time. Keeps your backends healthy, keeps them under a more consistent load. And then there's also some like web application or web server techniques, like this, I mean like web proxy type techniques you can do. Like understand your application, minimize your exposure. Don't install just every add-on. Don't do every single feature if you don't need it, because that's more exposure. It's more potential areas that you're leaving open that you don't know about or that you don't quite understand how it works, and maybe maybe it's some add-on that's not very well maintained. Provide robust, fail-resistant configurations. Always have something to fail over to. Don't ever let the user see server error or page error, like can't render page. Have static, you can even just have static copies of your site, so it's like never down. Can you block certain types of requests? Maybe your site doesn't even require posts. You can just only allow head and get requests or something. You got to know your application, know what you can block. Rate limiting you can implement too, but that's tricky if you're doing it at certain layers, because if you do it by IP, you don't know how many people are sharing that IP. Consider two-factor authentication, and consider how it's done. Okay, so one thing I had mentioned is if you did read-only, read-write server. The read-only and read-write server, if you do it, then you can have a different edit URL than public URL. So you can even have them on a completely different domain. So there's no way that a cookie would be shared, or maybe an attacker would be able to guess what URL to attack you with or something. And so you can even provide additional security in two-factor authentication, where you don't even, like, as long as two-factor is done right, it can provide another layer where you can't even access any part of the application until you've gotten past that first factor of authentication. So it acts as like a filter, or like a facade over your application. Wildcard, this is an open source project, and Wildcard open sourced what we use, and it acts as like a proxy. So no one's even allowed to see the underlying app until they done first level of authentication. And monitoring. Know what your traffic, what is normal for you, what normal traffic is. Know what your server load should be. Use the reporting tools that are available to you. There's so many good tools out there for getting statistics on your application servers, getting statistics on your traffic, sending you emails if there's abnormal activity, checking if your stuff is up or down, Logstash. Well, oh man, okay. I gotta hurry up. Sorry, guys. Vulnerability scanning. There's a lot of tools on OWASP for vulnerability scanning that will do automated vulnerability scanning for you. Add-ons and customizations. Be careful what you install, because especially with PHP, for instance, you just click install stuff often with PHP applications, and they're just putting stuff into your executable code directory. And in PHP, all it's doing is looking at a path and executing code. It's executing code on the file system. And sometimes PHP will patch itself. So it's patching its own executable code. I mean, that sounds a little scary, right? Where are these add-ons being installed from? Do you trust them? Do you know how do you update them? Is system administrators going to update them, or do people just click through the web interface? Do customizations run in a sandbox mode? Are they allowed to just run arbitrary SQL statements? Do you have reproducible builds for your customizations? Things you should think about so you can have robust, secure solutions. PHP is really popular, but it has had a suspect track record for security. Talked about this. Remember, I do Plone. Plone has a really good track record for security. We have never had a 0 day. This is our latest marketing ploy. Why is that? We do some things pretty well. We always check permissions before any view code is executed. So you can't even see the content of the page unless you have access to it. We're not executing scripts in a directory that can do potentially whatever they want. Add-ons aren't executing just random scripts in a directory that can do whatever they want. CSRF protections at the database layer. We have robust input-output filtering. Add-ons must be installed by administrators. And all through the web customizations are in sandbox mode. You're not able to do certain things. You can't just take down the server by doing a customization on the web server. Some final thoughts here. Take your security serious. Know your application. Know what you can do reasonably. All this stuff isn't for everybody, but hopefully you can take some of what I recommended and use it for your own organization. There's no perfect security. Everyone always has some exposure. There's always some risk, but you have to be okay with that risk. You have to be prepared to defend yourself and why you chose these decisions, why you did these things from a security standpoint. Your reputation, your users' data, things are at stake, your company, or your university, whatever it might be. All right, any questions, comments? Nothing? All right. Thank you.